Hey guys, welcome to Leetcode Weekly Contest 424. Um, Today we will see I'll go through the solutions of the first three problems, and yeah, let's get started. I think the contest is still running, still 40 minutes left. Yeah, let's see. So the first question, make array elements equal to 0. So here the question says that we are given an array of numbers of positive or non-negative integers, and it also contains zeros. Now, if it contains a zero, we will stand at that zero, and we can go to the left or we can go to the right. So, and our movement is such that if we ever encounter a positive integer, so that's in this case 1, our direction of movement will change. So we can always choose, let's say we want to go to the left, then we will go to 1 and we will decrease that 1 by 1. So now this will become 0 and we have to also reverse a direction, and then we will start going from 1 to 2. So let's say 1 0 2 0 3, this is an array, and let's say from here we choose to go to the left. So we go over here, we decrement by 1, and we go to the right to the next positive integer. We decrement this by 1 again, and then our direction again changes. And here, since everything has become a 0, we just terminate the process over here, since we can not change our direction to go back towards 2 and 3. And in this case our final array would be 0 0 1 0 3. And this is not what we want. We want to make all the numbers equal to 0, make all 0. But in this case where we were standing at this 0 and we wanted to go to the left, this didn't work out for us. So this is not a possibility. So this is not an answer. So basically we have to return an answer such that you stand at zeros and we go to the left and right, and we want to see in how many of such cases we can make the whole array equal to 0. Okay, so this is a very basic I think thing where let's consider a simple case. Let's say you're given element A, you're at 0, and you're given element A again. So in this case you can go to both left and right both. So our answer will increment by 2. Then this is because let's say A, and you choose to go to left. So A minus 1, go to right, A minus 1, go to left, A minus 2, go to right, A minus 2. And this will go on till, let's say this guy becomes 1, and let's say this guy is 2, okay? And we go to the right, this becomes 1, okay? So this becomes 2 again. Go to left 1, go to right 1, go to left 0, and from 1 it became 0. This was a 1, right? And we change the direction, so for example at the end there will be a case like this 1 0 1, where if you go right this will become 0, and then you change the direction again to go left, and here subsequently it will also make this 0, and then you will start going right. So this case, everything will become 0 in this case, A 0 A. And this can be extended, this idea can also be extended to a general case. So let's say all the elements to the left add up to A, there's a 0 over here, and all the elements to right of this 0 also add up to A. So then you can always extend this observation to this observation. You just compress this left segment into A, the right segment into A, and then you can just do whatever you want, increment the answer by 2 basically. So for example, let's say 1 0 2 0 3 0, this is an array, and we see that sum over here is 3 and sum over here is 3. So we claim that we can traverse in both directions from this 0. And this is true because let's say and this order doesn't matter, order of elements doesn't matter, it can be 2 0 1 as well. And you can see this for yourselves, because we will always have one valid direction to change whenever we encounter a positive number, since their sums add up to the exactly same. And one more edge case over here is this. Let's say you have a 0 and a minus 1. So in our example, let's say we have 2, 0 and 1. So in this case, let's try going to the left. So we go to the left, this becomes 1. We go to the right, go to the left, this becomes 1. Go to the right, this stays 0, this becomes 0. And since we decremented by 1, our direction will change again, and this becomes 0 as well. So everything at the end becomes 0, right? So, and let's examine the other case where we go to the right. So let's say we go to right, this becomes 0. We again change our direction to left, this becomes 1. We again change the direction to right, and there's nothing more to decrement. So our final array is 1 0 0. So we cannot go to the direction of the smaller element. We can always go to the direction of the bigger element, so that we have got always one extra turn to decrease our number, the bigger number. So in this case, increment your answer by plus or equals to 1. This is one edge case. So a is 0, a minus 1. So whenever your prefix sum is, let's say, so basically you maintain a track of these sums by using prefix sum, and the other sum is basically the total sum minus the prefix sum on the right hand side, right? And then you check if their absolute difference is at most absolute difference at most 1. You just check that, and if it's 0, you add plus 2 to the answer. If it's 1, you add plus 1 to the answer. That's the idea. Let me go to the code. So that's what I'm doing. I'm taking the sum of the entire array, and now I am iterating over all the indices. I'm keeping a track of the prefix sums, and now if I see that I'm standing at a 0, I'll check if are the prefix sums on the left and the right exactly the same, add to the answer, or else if they differ by at most 1, I add 1 to the answer. So that's it. Okay, moving on to the next problem. Zero array transformation 1. Okay, so here what we are again given an array. Leetcode loves arrays apparently, and we are also given queries. So queries basically indicate indices, a subset of indices that you can choose on this array, and when you choose this subset of indices, you decrement each element at that index by 1. Decrement the values, select indices by 1. So we are given 0 2, right? And here they are saying that, okay, so we are given 0 2, so we can select 0 1 and 2. So let's say this is your array 1 0 1, you're given 0 2, and you can select a set like this 0 1 2 and decrement every element by 1, minus 1 minus 1 minus 1. So this will become 0 minus 1 and 0. But this minus 1 is not possible, because we only want to go to 0, right? And we want to basically check if we can perform this and we can make our entire array equal to 0 or not by processing the entire length of the queries. Okay, so in this case what they have done is they will just select 0 and 2, so basically this one and this one, and decrement them both by 1, so it becomes 0 array. So we have written true because it's possible. And the claim is we don't care if numbers become negative, and this is because if they become negative, we can correct our previous turns. We can correct our previous turn. So what I mean by that is, let's say 101, and we are given a subset of indices 0, 2. So what I claim is that we can always select all the indices in this subset, and we can always decrement all of them by -1. And now I see this becomes 0, -1 and 0. So what that means is I know that I made a mistake over here, but I'm saying that I can correct that mistake. I can always say that, okay, it was my mistake, I selected the first index, let me not select it and make this number 0 back again. Okay, so in that case I'll just select indices 0 and 2, right? So similarly, we can always go back and correct our set of indices, so that's not an issue. And that's why it's always beneficial for us to pick the entire range and perform the operation on that range. So having established that, what we can do is we can do kind of a prefix sum thing going on here. Prefix sums. So the idea of prefix sums is, let's say at your PLI, you'll decrement it by 1, and at your PRI plus 1, you increment that by 1. So this is the range prefix sums that we do, and at the end you just take the summation of all the prefix values, right? And you just store them. I equals 0, I minus 1, pj. And this is a fairly common trick. Basically what we are saying is, we'll take a 0, let's say a 0 array, and let's say we are given a range of 1 to 3. We want to decrement all the elements in the range 1, 2, 3 by -1, right? Because that's the operation that we want to do. So what we are claiming is that let's go to 1 and decrement this number by -1, and let's go to Ri plus 1, which is 4. But 4 doesn't exist. 4 is over here outside. So we don't care. We don't want to increment that by 1. And now you take a prefix sum of this string. So prefix sum is 0 up till here it's -1, up till here is -1, up till here is -1. So what happened was we were successful in achieving our operation of decrementing all the indices by -1 in the range 1 to 3. Let's take another example. Initialize the array with 0, and let's say we want to decrement both of these elements by -1. So the range is 1, 2. So what we can do is we can do with 0, we can do -1. So do P of Li, decrement that by -1, and P of Ri plus 1. So Ri plus 1 is 3, right? This is 2, 1, 0, and increment that by 1. So let's make this 1. And we are doing this to undo our previous operations. This incrementing by 1 is being made to undo the previous prefix operations so that it doesn't affect the indices after the last element in the range. So now we take a prefix sum. So prefix sum is 0, -1, -1, and then this will become -1 plus 1. So it's 0 again. So basically we don't want the prefix sums to overflow in the range where it is not supposed to overflow. So this is a common trick, and this is what we'll do over here. So at the end you will get an array of you just get a prefix array of, it can contain 0, -2, -2, -3, and so on, elements like this, and we will add each of our nums to this array, right? Yeah, that's what we will do. So the code looks like this. We'll take a prefix array of zeros and we iterate over all the queries. So for the left endpoint we decrease by 1. For the right endpoint we'll check if it's in the range, and if it's in the range then we will increment that by 1. And now we take a prefix sum of all the prefixes. So basically this step that we did over here, we'll do that step to get our final updates to each of the indices, and then we check for each position. We try to increment it by pi, its final operation, and we check if it still remains positive, we return false, and if it is negative or 0, we can always say that our index picking was wrong, and we accept our mistakes, and we say that okay, we will not pick that index, we should have not picked that index, as I explained over here, right? So in all other cases we return true. So yeah, that's the idea. Let's go to the third problem. Okay, and now this observation follows over here as well. So we are saying here that along with the range, we are also given a value. So, and the idea here is that we have to go through each element in this range, and we can decrease each element by at most val I, which is the number that's given in the range. And we want to process the first k queries such that our array against becomes a zero array, and we want to find the minimum such k. Okay, so our observation from the previous question was that we don't care how much we decrement each index. All we care about is we decrement it by the maximum amount that we can, and for the sins of our past, we can always go back and decrement it by how much amount we wanted to make it 0. Let's say it overflows to minus some negative number, we can always decrement it by some lesser amount, right? So like, let's take an example. So in this case, what we can do is we got 202, right? And let's take 113. So we got the array 202, okay? And let's take a query like 0, 1, 2. Let's take query like 1, 2, and 3. So okay. So here we are saying we can decrement these two numbers by at most 3. We can also do like, let's say we make -0 and we make -2, because 2 is less than 3 and 0 is also less than 3. And we want to make a 0 array. So the claim remains the same. We don't care about our 0 array, we just care that we perform a range operation. So let's say, since this is 3, we'll decrement all the elements in this range by 3. So this becomes -3, and this becomes 2 minus 3. 2 minus 3 is -1, right? And now we apply correction. The correction is that this should have been 0, and this should have been 0 as well, right? That's the correction that we want to apply. So we want to add back a 3, and for this guy we want to add back a 1. So this is the corrections that we want to apply. Okay, so now when you apply these corrections, what that means is that so 0 went to -3, and we are claiming that we shouldn't have done a -3, we should have done a +3. This is the correction. And your 2 went to so you again decrement all the numbers by -3, right? So this came to -1, but we want this to go to 0, so the correction you apply is just add a 1. Okay, so what's the net correction? Net correction is -3 plus 3, so you add a 0. This is the net correction. Add a 0, and -3 plus 1, that is you decrement by -2. Basically you decrement by 2, like net correction as in decrement by what number. So what we are saying is, since we can select at most 3, we will, since this is an array, we will decrement this by 0 and we will decrement this by 2 from our net correction. Okay, so what we proved here is that our net correction always remains within the at most range, since it cannot go beyond that, since we are decrementing it by the maximum value. So our net correction should remain within the maximum value when you try to correct it actually, and when you add it up, that's what the net correction you get. So the idea again remains the same. We will go to each array, we will go to each query, we'll do a prefix something going on, like plus, so p of, this time p of li plus equals to li we will do, and p of ri plus 1 minus equals to li we will do. Sorry, my bad. We'll do a minus equals to over here and a plus equals to over here, since we are decrement. This is a decrement operation, right? So same idea from the previous thing. And one more idea over here is that since you want to find the minimum possible k, we'll just binary search on the k. Binary search on k. Because if we can make the array 0 with, let's say, first 10 numbers, we can always, like, we don't need to go and search for the greater k. We always want to reduce the k, and we want to search for a better answer. And same goes for a similar case. If we cannot make it with 10 numbers, then there's no way we can make it with 5 numbers, right? There's no way we can make it with 5 numbers, yeah. And if you just go to search for a bigger k. And the thing is that, yeah, that you just binary search on the k and you just get an answer for that. Let's go to the code. So this is the code, and the first thing you will check is that if all the numbers are initialized to 0, then you don't need to perform any operation and you just return a 0. Else you binary search on the k. So k's index would go from 0 to queries of size -1, right? So you perform the operations up till that index. And let's say your m is the index, and you take the prefix sum array and you take a temporary array of nums, and you iterate over all the first m queries, do this operation minus equals to, and also do this plus equals to operation that we saw, and we take the prefix sum of prefix sums, and then we check if t nums of I is positive. That means that even if we utilize a maximum element, we couldn't make some number 0. That means that this is okay equals to false, and we want to search for, so we want to make more operations on this particular number or numbers like this. And if it's okay, so okay was initialized to true, that means we managed to successfully get a 0 array. We store the minimum answer in the index, we go to the left search space to find a better answer, else we go to the right search space. And we initialize the answer with the maximum queries, and like if that is the case, we return -1, else we return answer +1, since answer represented the index up till which we wanted to iterate. So yeah, that's the idea. Thank you guys for watching, and hope you liked it.